Okay, hi everyone. Today on the pod we have got Will Brown. I expect you all might have seen the face on Teapot. He's someone who's quietly shaped a lot of how people think about RL agents and reasoning in LLMs. Before we dive deep into this pod, I'll introduce about Ground Zero. So yeah, Ground Zero we do a lot of foundational steps as I said. We are teaching and talking about linear algebra. We have a recently session with token bender as well, which was a hit. And probably we'll be coming up with more exciting this pod and talks coming up soon. So I guess we can start from the next slider. So we'll work across some of the most interesting places in AI, from building RL pipelines at 2 Sigma and doing privacy work at AWS to experimenting with LLMs at Morgan Stanley. But what really sets his work apart is how structured and intentional it is. His generative AI handbook became a go-to for folks entering the space. His open source library like verifiers, and he thinks deeply about where RL meets a language, how agents actually generalize, and what it takes to build a self-improving system. So he now leads research at Prime Intellect, where the focus is scaling reasoning, not just scaling parameters. We are going to talk about agents, reasoning, reward hacking, self-improving loops, and some trivia as well, and where all of this might be headed, let's see. So, well, super pumped to have you on. Welcome.
Awesome. Great. Thanks so much for having me on. And just to clarify, I'm not like the lead of all research. We have a couple of research leads. But I have an area where I'm kind of like deciding
Okay.
how we think things should go.
I remember once
Yeah,
calling
yeah.
you are single, highest leverage individual, versus I right now. And I see like we all on Teapot know about. So
I don't
it's
know
pretty
about that, but
yeah,
Kalomaze is doing a lot of great work. We work closely together. But yeah, it's been quite a ride.
cool. So you have had a very pretty unique trajectory, starting with RL, then working on privacy at AWS, and now diving deep into LLMs and agent research, doing open source stuff. So what did that path look like from your perspective, and how do you see it basically?
Yeah, so for me, like I was always really into like math and algorithms and I like programming, but it was really like the math was what got me excited, like thinking about like graph search algorithms and sorting algorithms. So those were the classes in school that I really liked the most. And I was trying to find I didn't really want to just go like be a software engineer. Like I kind of did the internships and tried it out. But I was kind of more drawn to the data science side, the algorithmic side and but I was looking for a thing there that was exciting. And I think a lot of the data science people were doing in like 2016, 2017 was like kind of cool, but a lot of it was just like fancy linear regression. And the thing that really was like an AGI moment for me, I think, was AlphaGo, and also seeing the early reports on self-driving cars. Realizing that, okay, deep learning like works, it's a thing that you can scale. And the version of that I got the most excited about was multi-agent systems. It seemed like, okay, at some point, this AI stuff's all going to work, and we're going to have these crazy interactive agentic systems all over the place that are learning via self-play, that are learning via experience, because that's what seems to be working for self-driving cars at some level, as well as for games. And those to me seemed like, well, if you can do either of those, you can probably do other things as well. I didn't know that language models were going to be the way. In hindsight, it seems like, of course, it's got to be text, but I think no one knew in 2017 really that like this was going to be the path. I think it was like 2020 people really started realizing like language model scaling was going to work. But at the time I was like, okay, multi-agent systems, great. And then I was also really deeply steeped in the math, and it became clear to me that like there were some core open questions in the theory of a multi-agent systems, of understanding like what actually happens if you have a bunch of learning agents go out into the world and learn interactively. How does the system evolve? What algorithms should you use to learn in the settings? How does this change from the supervised learning setting? How do you make algorithms that are aware of the fact that they're learning in the context of other agents who are also learning? And so that was kind of the backdrop for my grad school research. I was like, okay, like kind of the short version is that in like 2-player games, things are nice and easy. And a lot of like deep learning at the time was building on primitives from 2-player games. So GANs were kind of the canonical example, but also a lot of other kind of more theory algorithms where you kind of have this constrained optimization problem of like maximize A subject to B. And the way you do this with deep learning with gradient descent is you have two sides of a game to learn to find an equilibrium. That all kind of breaks once you go beyond 2 agents, and once you go out into multiplayer games or games without a zero-sum structure, which is kind of what the real world is like. And then there's all sorts of these fun examples from the field of algorithmic game theory about kind of these edge cases that pop up, these kind of bad examples where equilibrium behavior is like not what you want because there are like many equilibria and some are better than others, or like you have prisoner's dilemmas or tragedies of the commons. And it felt like if you just naively scaled deep learning in multi-agent systems, you might end up with these like tragedies of the commons. And like I think that's like one question that's always been important to like think about is like we want to like make these systems like locally good at doing problems. We also want to like have this whole thing go well. We want to have the trajectory of like AI development, AI adoption be the kind of thing that has people working together when they can, rather than ending up in bad equilibria where everyone's like race to the bottom.
Pretty interesting, and I guess it has been a journey for you. I remember, like I guess 6-8 months back, you used to talk more about RL theory, and I guess that was pretty interesting to see on Teapot. And I guess a lot of people have actually kind of encouraged to explore more about it. Interesting. Like actually, this thing also excites me to dive deep into what motivated you to get into this. So like what pulled you in early, any papers, people, or moments that really shaped how you think about research today? Also, I'm curious about how did your PhD experience in Columbia fit into all of this? Did you solidify your direction, or were you still exploring back then?
Yeah, so I kind of in undergrad, I kind of figured out the set of topics. I had a few different other things I was thinking about. Like at the time, especially with the group of people I was working with, I was an undergrad at Penn. There were a few professors working on kind of learning theory topics with a kind of societal focus. Some of that included like algorithmic game theory, but also things like privacy. And so there was a lot of really cool math as well as also really cool like storytelling about these problems, about like, okay, here's a real world thing that's a machine learning problem with a twist. Maybe it's multi-agent, maybe you have a privacy constraint, something like that. And then you got to go do the math and figure it out. And that to me seemed like a very fun direction to go. And so I knew I wanted to do something like that in grad school, where it's like, it is machine learning, it is theory, but there is a story being told under the hood about something out in the real world. And then in terms of formative papers, I think the set of results that to me kind of was the core backdrop was a thing I learned in undergrad, which is about the interaction between no regret algorithms, which are kind of like the online version of gradient descent. So no regret learning is kind of regret minimization is just the time varying or online version of optimization. And this in the context of games, basically these algorithms reach equilibria in zero sum games, usually if you set everything up right. But the space of equilibria you reach in general sum games is a thing that's an object called a correlated equilibrium or a coarse correlated equilibrium. And these things are like, they kind of look like linear programs if you look at them from one angle. They also look like chaotic dynamical systems from another angle. They don't converge in one sense, but they do converge in another sense. And there's like, they basically seem like these abstractions, these primitives that were a very powerful lens for looking at the evolving behavior of complex systems. And so that was kind of like my focus was like, I knew that like I had done some work in multi-agent RL. I had been really interested in algorithmic game theory. And I was just like, okay, the pie in the sky question, which I never like fully like got a real answer to, because I don't think you can get a real answer to it, is just like, how do you design algorithms for kind of optimal competitive and cooperative learning together in these systems? But there are versions of these. So I found versions of these problems where it does become more tractable. And so that was kind of the takeaway from grad school. It's like, okay, and this is what you do a lot in a PhD, is you have some really big question that you know is kind of impossible. And then you start small and try to meet in the middle somewhere. And I feel like I'm pretty happy with how that went. I got a good understanding of a set of problems, especially ones where there's some techniques you can do that are kind of fun that I figured out along the way about doing optimization with other agents who are also optimizing, and how do you kind of convert this like multi-agent learning problem essentially into a single agent learning problem, because then the math is much easier. but you have to kind of like do some reshaping and differentiating and whatnot. But it was really formative for sure. It was like the whole experience I think was really like good training for thinking about these kinds of systems. And I find myself like referring back to those same kinds of concepts all the time in when I'm working with LLMs, especially like now people seem to really want to do multi-agent LLM RL. And it's like, okay, that's a version of multi-agent RL. Let's figure out multi-agent RL. And it's complicated. Like a lot of these problems of kind of knife edge, multiple conflicting constraints, if you write down the math, they actually become versions of these problems where it's like, there actually isn't a clean answer some of the time. It's like, if you want to maximize A and B, and you don't know how A and B trade off and you can't compare them linearly, it's like, well, this is a hard problem. There's not necessarily always a clean answer.
Interesting. I'm curious about what role your advisors, like how you see it, the roles of your advisors, how you played in the entire duration of PhD, and how much this has impacted the whole journey of PhD. Yep.
Yeah, my advisors were incredible. Tim Roughgarden and Christopher Papamuccio are very much kind of like giants in the field of algorithmic game theory who are responsible for a lot of like both understanding like the kind of the examples I'd mentioned of like, oh, these bad things that can happen, as well as the complexity of understanding some of these problems. And they had done some of the seminal papers of the things I was reaching on. So the other day I tweeted one called Strategic Classification, which is this idea of like this game where you're trying to make a classifier, but you know the people who you're going to be classifying are trying to game the classifier.
Sure.
And so you have to think about making like gaming robust models, classifiers. And that's like kind of the problem we all have to deal with now. And so Christos in 2015 wrote that paper because Christos, I think, is quite good at seeing into the future and realizing a thing is going to be important and then figuring out the kind of concise formulation of the problem that makes it something you can start studying with the tools of theoretical computer science.
Pretty interesting, and I guess that has kind of simplified the journey as well. Next would be like I saw your recent tweets, like you have like your love for teaching. So how you define this love for teaching and open source stuff? I guess you have just posted a while ago, if I remember. Yep.
Yeah, I always have like I did a lot of TAing in undergrad, so I especially in computer science in a lot of US schools, like the computer science grad students don't have to teach because that's like, I don't know, the departments are well funded. But one of the trade-offs means that you still need TAs for the classes, and so these TAs end up being undergrads. And so I did a lot of undergrad, like after freshman year, every semester I was TAing for at least one class, and like holding office hours and writing homeworks and sometimes doing like breakout sections, smaller teaching sessions. And I always really enjoyed that. Like I think, and that's part of like I think why I like tweeting, which is like I think it is a really good process for my own learning to have to take something that's complicated that I mostly understand or I kind of understand and have to explain it to someone else, because then I have to really understand it. I have to like be able to answer the hard questions. And sometimes it's like someone will ask me a question, it makes me realize I don't fully understand something and I got to like figure it out on the fly. Or I have to take some concept that like it's a 30-page paper. How do you communicate this in 5 sentences? This distillation, the compression process, I think is learning, like a lot of learning is this compression process. And I think teaching is a very good way to kind of force yourself to do this compression process. And so both back with the handbook that you mentioned, like for a lot of the reason I wrote that was like, I knew that all these things were important. I knew they were all interconnected and I could see most of the picture, but I also wanted to like really make sure that I understood these things. And I was like, okay, let's just like map out all the concepts and start like collecting links. And this came together over the course of several months. Like I think I released that in June 2024, but it was the kind of thing I realized in like at the start of that year, and I really started working on it in February 2024. And then it kind of the last few weeks were a big stretch, but I'd started knowing, okay, there's this project I want to do of this handbook thing. Yeah. Let me start a Notion doc, and like every time I find a good blog post that I really like, I'm going to save it in there and start making sure I'm covering all the bases at the time. And so that to me is still a version of the same process of like taking all these things, trying to map them together, find the connections, and yeah. I think like the handbook totally missed the reasoning model thing, which wasn't really real at the time. But I think other than that, I'm still pretty happy with the coverage there. I think it, beyond reasoning models, it does hit on
I would be
most.
surely grateful if we can somehow collaborate on this and can extend it. I guess, yeah, reasoning on the reasoning side, a lot of us to be done. But yeah, it is pretty much like if someone reached out to me about this, like resources people ask for. So this is one thing I just directly refer. And to be honest, I still remember stumbling across the GenAI Handbook. Like once I guess this was my first gentle introduction to yourself. It felt like someone had finally put structure to the mess I was trying to learn, and that is why I reached out to as well. Actually, what was going on in your head while making it? Like, was it one of those I wish I had this one when I
Yeah.
started projects, or did it evolve into something bigger along the way as you have progressed? Yep.
Yeah, I mean, so I often come up with a lot of ideas of things I want to do that are just kind of unrealistic. That I'm like, oh, this would be awesome. This would be great. This shouldn't be too hard. But then you have to find a version of it that actually becomes realistic. And so when I was I was learning all this stuff. It was like, there should be a textbook on this stuff. Why has no one written a textbook? And it's like, oh, well, writing a textbook is really hard and takes like 3 years. And this stuff is moving so fast that you just kind of can't write a good textbook that covers all of it. And all of the things that were like textbook shaped at the time were like pretty outdated or were just kind of like junky. And so my light bulb idea was, oh, I'm not actually going to write it. I'm just going to compile it.
Yeah.
I'm going to write like a paragraph for each thing, but it'll be like 50 things. And that felt like doable. And once I had that idea of the shape of it in my head, like, oh, it's really this thing that can be kind of very high coverage because I'm kind of importing most of the content, that started to feel tractable.
Pretty interesting. That's, I guess, like everyone should check out this if they are starting with this. Is all resources from classical ML to deep learning to agents, reinforcement learning, and with the current stuff. I guess we'll be working on and do the extended part of it as well in coming time, maybe soon. So the next part will be like where the major agenda of this podcast will be around RL, reasoning, AI timeline, postage stuff. So the first question which I have got is this concept of rubric engineering, that is turning fuzzy goals into trainable structures, feels like a dark art right now. How do you approach designing these rubrics? How do you know if you are actually reinforcing the right behavior along the way?
Yeah, so the easy version is if you're doing a problem where it's easy to check if the answer is right, then you kind of have a very natural reward score. If it's math or if it's code, then it's just a matter of engineering the thing that's going to check the thing. And so for math, this can be kind of annoying. People have done a lot of work of like making these math parser libraries that do a lot of edge case checking for like fractions and stuff like that. And for code, it's test cases. But I don't think there's a few papers to me that seem very promising, but I think as you go to more real world tasks, there's like two forks you can go. There's one, which is like get more creative with verifiable tasks, which is like things like reasoning gem, some of the work that like Kalomaze talks about, where it's like there is some signal in a thing that isn't like a right answer, wrong answer verification. And so I tend to use the word verification as a very umbrella term, for better or worse. It's checking a property. And the property doesn't necessarily have to be right answer. Because sometimes the answer is not the sort of thing where it's like right answer, wrong answer. It's like, how good is this?
Sure.
How do you verify how good something is according to some criteria? And so like board games, I think, are the kinds of things that people are going to have a lot of fun with. I have kind of been hoping people would come back to board games for quite a while. They're near and dear to my heart in terms of kind of old school game theory. And now it feels like people are ready to do some real LLM game RL. So I'm very excited to see that, and I've done a little bit of work on it. But that is kind of one of the goals of like Verifiers, the library, is I'm hoping we've integrated it with a few of these kind of gameplay toolkits like Text Arena and Reasoning Gem. But I think there's a lot more to go in terms of making it something where people can pretty easily do like RL for games. Yeah, in terms of designing these for like arbitrary setups, it is kind of a dark art still. I think the way I'm hoping it goes is that you can start with higher level specifications or kind of small seed data that captures what you mean by a good answer, and that you can kind of turn this directly into a reward function. I think this kind of framing comes up in some of the DSPI discussions. Omar's a friend. We've chatted a bit about kind of how this stuff goes, and I think there's a bunch of what he says that I resonate quite a bit with about like how ultimately you don't want to be fiddling with these prompts. It's kind of a stopgap solution on the road towards something that's more scalable. In the context of reinforcement learning, and especially with things like avoiding reward hacking, I don't think we really know what this algorithm is going to be yet. Like, what is the optimizer that allows you to create dynamic rubrics on the fly that actually capture the goal of the task? Because like the goal of the task is like this fuzzy thing. The hope would be that like LLMs are really good semantic priors. Like there's a lot of knowledge in the weights. And so if you say something like, I want an LLM that like writes a really good essay, this can be interpreted many ways, but there should be like, at least if you fix a given base LLM or a fine-tuned LLM, there should be an algorithm that, whether or not it's a good reward function, it's a like robust and reasonable reward function that will express some kind of aligned behavior via things like sampling criteria for rubric bullets of like, let's say, like here's a trick I did with Claude initially that kind of gave me the feeling, this was like one prompt I did, that gave me the feeling that, oh, this is probably doable, was like, I just at some point asked Claude to give me a list of descriptions that make things funny. And I told it like, okay, give me like 20 of these things. These should be the kinds of things where like a mediocre short story is gonna maybe have 7 or 8. And like a masterfully written short story by one of like the legendary comedic writers is gonna have like 18 out of 20.
Yeah.
And I looked at it and was like, oh, these are actually quite good. Like these are principles that describe the sorts of things that make things funny. And some of them were like quite subtle. It's like, oh, does this, making sure that things like jokes aren't overused, or that like if there's a punchline, it is like appropriately alluded to without being heavy-handed. And like those are the kinds of things where LLMs have a lot of this knowledge about these properties, about problems. They don't naturally enforce all those properties with kind of next token generation, but it feels like we can maybe elicit these properties and have those become parts of these rubrics.
Interesting. I guess this pretty much give idea about like it's still dark art, and I guess hopefully we'll be looking up to certain improvements as well in the given direction. Next is about there's this idea that RL agents in language space have to find their way through reasoning, not prompting, not instructions, just pure RL and reward. So why does that process work, and why does it seem to produce reasoning behavior better than you say in just instruction tuning? Yep.
Yeah, so I mean, like at some level, all these are just training algorithms. Like there's different, the loss functions are a little different, but at a high level, the sorts of things if you had, like, I mean, people have seen this with small models now. Like if you want to train a really, really good 3B parameter reasoning model, most people actually don't do RL. They do distillation or essentially instruction tuning.
Yeah.
And so the reason they do that is because now it's incredibly easy to make instruction tuning data from reasoning, because we have these reasoner models now, like R1, where we can just like hit go and we get all this data. But before we didn't have that, and like manually collecting human reasoning data is really hard. It's really expensive. Only the big labs were able to even try, and even then it was not the thing, because the way that like humans weren't actually solving these math problems with true step-by-step reasoning. Humans, when they were writing an answer, they'd probably work it out on paper, they'd think about it, and then the thing that would show up on the paper is like the presentable version, but it's not actually the discovering version. And only so much computation can be done in the weights for the LLM. You kind of, and people had known this for a while, that you want to give them a scratch pad. They can do better work when they have a scratch pad. But it just turned out that like if you wanted to get them to use the scratch pad well and discover good scratch pad strategies, it's hard to kind of put those in from human data. You need enough human data so that they have the pieces. And so I think this is one of those reasons that people mention of like, oh, there's more reasoning data on the internet now because of earlier LLMs, so that later LLMs, when they're pre-trained, have seen more examples of chains of thought. Because we had all these papers of like eliciting chain of thought through crazy prompting, and some of those traces end up on the internet, and now those fold back into the LLMs who can then take those and bootstrap. And in some ways, this is like really what RL is doing anyways, which is that you heavily sample, you really like do higher temperature exploration of the space of possibilities. You find ones that work and you double down.
Interesting.
And so, yeah, you don't really get to do true exploration in the instruction tuning space. RL kind of does exploration via sampling.
Yeah, like also I guess this is the reason pretty much like after every RL, like as for DeepSeek V3 as well, they started with her, but at least at some stage they have incorporated the this instruction tuning stuff like SFT and get started with there. Interesting. And let's start with this one of your more classic libraries and project verifiers. So I will just ask like how you come up with this verifiers on GRPO and what's the journey been like from there. What are the ideas coming up and how it went so far? Yeah.
Sure. Yeah. So I had this suspicion back in like later 2024 that tool use was going to be important.
Yeah.
I think people had been doing function calling for quite a while. Like every like API supported like calling a tool at the end, and people were kind of building agents around this, but none of them really worked very well. They all kind of sucked. And there were a couple like Kaggle things that I didn't actually submit anything to, but I just spent some time thinking about. One was our prize, the original one, and then also the math AMO competition, where I was just spending some time thinking and testing out like, okay, if you really wanted to like solve these robustly, what would you do? What would be the model? If it would be some kind of language model that does some kind of sampling strategy, and the hope would be at the end that you have an output that's quite good, that matches the input. And the obvious trick to me that seemed like there's a lot of directions you could go, but the direction that seemed the most promising and the most like, I don't know, scale-pilled, bitter lesson without going too deep in the weeds on like custom architectures and whatnot was like, just let the models use the computer. Like there's a lot of art problems that there are simple programs that discover them. People had tried the like brute force DSL search thing. And it was like, well, that's just tool use. Just like let the models use tools and train them to use tools well. And it seemed like eventually you'd want to do some RL because RL is kind of the natural way to discover these sorts of things. I think the combination of long chain of thought and RL was not obvious to me at the time. But once some of these models like QWQ and the preview DeepSeek started trickling out in 01, it was like, oh, okay, you need a little bit of thinking there. And so in like December 24, the project I'd been working on was essentially just building what was the earliest version of verifiers that never actually was released as it was, but it was a similar like tool called harness eval setup designed for creating SFT data. Where it was the sort of thing where I was initially just like plugging in models, having them give them some math questions and let them do multi-turn tool use, and then evaluate the outputs. And at the time, I was doing this for SFT mostly, where I was planning on doing like SFT from rejection sampling. And so the first experiments I did where I would take models like DeepSeek V3 and Quant 72B and just create a bunch of these traces from them and then filter them based on correct answers, and then training 70 models on these. And they actually would work. Like the models would get quite good at using the tools. I think the problem was that like I was doing this on like Quant 7B math, which is already such a saturated math model. And so it was in some like you would see a lift on like the harder benchmarks like Amy. Yeah. But in like GSMAK, it's like kind of just noise. Yeah. And then I was trying to do, for a while I was trying to get DPO working, which I think in hindsight was probably not, I hadn't realized, I knew that PPO was going to be too tricky, and I wasn't a believer, I guess, in the kind of neural critic model. I wanted something sampling based. I hadn't really doubled down on GRPO, and I think the world had not yet realized that GRPO was kind of the trick. But I was also just thinking, okay, I'll try the easiest stuff first, and then I'll progress up the ladder. And so like GPO and KTO were really like what I had tried to like not great success. But then like this kind of brings us to around when R1 came out.
Yeah.
And R1 was like, oh, you can just scale up GRPO and it works.
Yeah.
And we hadn't had a signal that you could just scale up sampling based advantage estimation and have it work so well. And so I was like, oh, that was the missing piece. And like the first thing I did was like, okay, let's try it. Let's just see if this works at all. And so at the time, like Hugging Face had like just released their GRPO trainer. And so I grabbed that and was like, okay, some of these like formatting bits I'd already had in my code before for like filtering functions and just formatting. And I was like, okay, let's just plug this, like do the simple version, one file GRPO demo. And so that was the GRPO demo script. That kind of got some traction. People seemed to like that. And then I was like, okay, let's combine this with all the tool use stuff, because no one had really been doing like GRPO for tool use.
True.
And it seemed like a very natural fit where you could just like sample these trajectories, have these advantage estimations at the end, and like have this be something that can work with tools in the loop. And so that's kind of,
that was a whole trajectory as well. I remember, yeah, I did that as well. Omar has kind of used that in DSPy as well. It is a like really good framework for prompting, and Kalu has shared a full fine-tuning demo as well about it, and pretty interesting. And I guess it is really being used for at least for the tool calling, and we have actually seen a lot of optimization given the labs and stuff. Yep, sure.
Yeah, GSPy is great software that I take a lot of inspiration from in terms of thinking about building blocks. And I think like there's certain things that Omar says where I'm like, I'm not sure if I agree, but then there's a lot of stuff where it's like the way that he thinks about software, I think is very correct. And so like Verifiers very much is targeted at optimizer research and reinforcement learning research. It is not the people who should be using it are people who are like doing RL research as opposed to like building user-facing LLM systems. Whereas I would say like DSPy is intended to be like a little higher up the stack where the users of it are people who want to just make a thing that works. And so I would hope that, and I talked to Noah, who's leading the Arbor integration with DSPy, and I talked to him quite a bit about ways that ideas from verifiers can be helpful and vice versa. There will be more interoperation between DSPy and verifiers in the future. Definitely eager to do that. There's a lot of ideas that, like what I was mentioning back of like, how do you extract these like rubrics dynamically? The way I'm thinking about that is essentially as a DSPy program. Like, what is the DSPy program that will elicit the correct process for generating these dynamic rubrics that is going to be robust, and what's the signal that's grounding it? And I have some ideas. I won't get into all of it right now, but I think the way of thinking that it frames is quite nice.
Pretty cool. And yeah, looking forward how it can scale from there actually. So the next would be like if someone wants to run RL experiments on smaller language model, let's say 1 to 3 billion scale, what would you recommend? Are there setups that still teach you interesting things, even without massive compute? Yep.
Absolutely. Yeah. So this has been kind of one of the big goals, is figuring out how to make this stuff accessible. Like, I think the ecosystem is in kind of a funny spot in terms of the tools out there. Like, there's some tools that are intended to be super user friendly, but I think they kind of fall into the trap of trying to please everybody and end up being like, I don't want to name names, but there's a lot of code bases that are what people reach for, which are kind of nice if you just use them as, but they're not necessarily the most hackable. And then there's kind of very like production facing, like serious, like industrial grade frameworks. Those also feel bloated to me as well. Like Veril is the canonical example that I will mention, because I think of it as like the sort of thing that I can see why they did it the way they did it. There's certain things about it that are kind of probably really convenient once you're in it, but it's really difficult to get started. It's really not accessible. You have to do things a very specific way. You have to read lots of the code to understand how things work. It's not something that you can kind of get started in a few lines of code in a notebook. And I was like, okay, what's the accessible version of agentic RL? And that requires being able to do things on small models. And so I needed to spend a lot of time figuring out, like, how do you, like, what's the right recipe to reliably get this to work on small-ish models? And I think the important thing first is difficulty calibration. There's some things that will just be too hard to work on small models. That doesn't mean you can't do RL research. It just means you need to do RL research on the right kinds of problems for your setup. And thankfully, like, this is actually a thing where you can get, I think, pretty good intuitions. You need your model to be able to do better than 0. If you plug in a model and it's stuck at 0, it's not going to go anywhere, really. It's going to just stay around 0. You want it to get off the ground. Once it's off the ground, this is when the RL magic can really take effect. And so how do you take a small model and get it above 0? Well, you can do SFT. You can, like, distill from a big model. And so the trick I use all the time, and I tell people to use all the time, is take DeepSeek V3, make an environment, plug in V3, sample a bunch of trajectories, filter based on your reward scores to the good ones, do SFT on this for a few epochs. You can do this pretty cheaply in, like, the training runs. These SFT runs take like 5 minutes.
Yeah.
Because I'm doing it in like 1,000 samples. But now you have a model that's better than 0, because it's like DeepSeek V3 is a great model. It's going to be better than 0 for most things. And so, and you can kind of import that specific version of V3, that specific skill set, into your small model. And so you can actually do RL. You can see the reward curves go up without crashing on, like, a 0.5B model for the right difficulty of task. And so that's been very cool to see.
Yeah, I guess this is pretty much talked thing on Twitter or anywhere, like how to run these experiments on their own, given the compute and resource constraint on the side. And hope, like, this would give pretty much idea to people to get started with RL experiments, given the very sheer amount of compute, and get results at least, and how it goes there. Sure.
Yeah.
The next is about how you see decentralized training and inference transforming AI research and deployment in the next few years, and how Prime Intellect is working around it. I guess, like, we really expect, we really see Prime Intellect is working around this stuff only, how to make things more scalable and decentralized stuff. Yeah.
Yeah. So it's really interesting. And I think the way that I think about it the most often is from, like, a finance angle, actually, which is that, like, everyone talks about, like, compute is the new oil, or energy is the new oil, like, but these things are, like, expensive specific chips that live in buildings, and only one person can use them at a time, and some people have them and don't use them, and getting them to work for your setup is kind of painful. Like, moving between NVIDIA and AMD is, like, really hard. Moving between, like, versions of CUDA can be hard, depending on what your training stack looks like. Moving, like, your setup from, like, one type of NVIDIA GPU to another, or, like, going from single node to multi-node, like, all of these things add complexity to your system that is not very fluid. And I think it's hard to make it all fluid. Like, part of these things are, like, the nature of the space, because things are, writing code that works on any kind of device is hard. But I think it creates an opportunity for thinking about these things as markets, where if you want a GPU market to be a liquid market, if you want it to be a market where things are interchangeable, where things can flow fluidly between stakeholders, between owners, where someone can say, oh, I have this extra compute, let me give it over here, and someone else can use it effectively, you want to be able to take advantage of this compute without it needing to all be in one pretty clean data center. Because, like, today, like, most big LLM training runs, it's like they got one really big data center where lots of chips with, like, full interconnector, all the same chip. Yeah. And that, like, makes your life a little easier. But if you can solve the engineering problems required to allow interoperability, now it's not just these 30 clusters. It's like the cluster can be anywhere. You just need enough. You're adding up flops. You're not adding up, like, large data center. And so if you can kind of mix and match, if you can create these setups for inference or training that take advantage of kind of heterogeneous scattered compute, this is what you need to really unlock a liquid GPU market, in my opinion, because now you have this fungibility. And so that's like my PI thesis. Yeah. And so to do that, you need to build services on top. You need to build infrastructure on top. And RL is like a very natural one, because like RL is like, on one hand, it's like pretty compute intensive, but it's also accessible in terms of compute intensive. It's much more accessible than pre-training, where people can do RL at very small scales and make a thing that's actually useful for them.
Yeah, I guess.
And I imagine, yeah, go ahead.
As a independent experimentalist and people who are just starting out, this one thing already, like if some certain sort of pre-training is being done, so we can kind of just play nut and bolts and do a lot of things coming out of it. Yeah. Next would be, this question I've got about what's your take on self-improving agents trained with RL? Everyone loves the idea, but making them work in production where things break, drift, and scale is a different game. So, what actually needs to be true for that loop to be stable and useful in the real world?
Right. Yeah. So I think full self-improving in the sense of the agent is not just answering questions with some auxiliary verifier, but is kind of doing its own verification or self-verification or generation of questions and answers. You need some sort of anchor. You need something that is kind of grounding the goal of the agent with something concrete. The hope is that this thing can become less and less concrete and become more abstract, high level. Like, it would be beautiful if you could just have it be a prompt, where the prompt is, I want an agent that is really good at using a Python REPL to solve pandas data science problems. Okay, great. That's my prompt. The current way is you would determine a bunch of tasks. You would manually come up with some program to generate these tasks that look like data science problems. And then you can, plugging in the tool is pretty easy now. You can just kind of give it the ability to use Python as a tool. And then the answer would be, you'd have some ground truth from these generations, where it's like, you need some kind of clever trick to come up with questions where the answer is like verifiable based on like, there's some number that comes out of running some pandas program, or some example data frame that comes out of a program, and you just compare these two to a ground truth. The hope would be that this process can become more automated. To me, that would be what like a self-improving agent really is something that can come up with its own training examples, as well as the rules which can be used to verify them. And this is hard because some problems, like, if you can, how do you know if you've solved a problem? If the thing is creating the problem and judging whether it solved it, like, it needs to know the answer is right. But if it hasn't been trained with these things yet, how does it know the answer is right? Like, you do kind of have this circular problem that you have to get around. And so I don't think you can just like do this for anything right away without some sort of grounding. And so that's, I think, where the idea of rubrics is useful, which is that, like, you want to determine properties.
Yeah.
And some things could be like, is the code running correctly? Are there redundant steps in the reasoning? Are there large misunderstandings? And so if you can verify these properties of a reasoning trace, maybe this doesn't actually fully verify correctness. And there's also, it opens up the door for reward hacking. The hope would be that you can robustify this and make this something that allows you to take whatever is already baked into the LLM, not necessarily as like outputs, but as like world knowledge about correctness of these problems holistically, and extract this into a form that can be used for verification. It seems like, at least for some problems, definitely possible.
Interesting. And I guess since past few weeks, some novel work has also been coming up around this, and really expect something really like comes up and solve this problem at certain extent. Next would be about GRPO. Like, on the same line, GRPO seems to work well for text language, but does it scale to multimodal settings too? And if inference gets fast enough, let's say at grok level fast, do you think it becomes viable for real world robotics where latency actually matters?
It's a good question. So for multimodal, it's kind of just an engineering problem. Someone is working very hard on a PR for verifiers for multimodal support. I'm very excited, but I also I know that it's hard. I can see he's been working on it for quite a while, and I'm like, I can look at the code and be like, oh yeah, there's a lot of like really tricky things to figure out just to make the implementation details work and to not cause other problems. And so it'll happen when it happens. Other people have done it, of course. I'm not the first person to try to do it. And like it seems like it works. Multi-turn, multimodal is a little tricky. You got to be a little careful there because like the O3 style of thing where you modify an image, like this is obviously very cool. You have to be very careful about how you handle the output tokens. Zihan Wang, who's a PhD student at Northwestern and was at DeepSeek previously, has a great paper diving into this. Get the exact title, but talking about like the kind of considerations in doing, and he's doing it from a perspective that he ends up using PPO, but he's doing it in a way that's kind of compatible with both. Like GRPO versus PPO, we'll see. Like I'm still bullish on like sampling based RL where you don't need an explicit correct model. I don't think it's going to be like literally GRPO as is stated, especially because GRPO already is a little funny for multi-turn. And I don't know that it's really the right algorithm for super long horizon, long trajectory problems, because you have like part of the magic of GRPO is you kind of have this natural branching process that explores different trees. And it turns out for like R1 style math questions, 10,000 tokens with, let's say, I don't know how many samples they're doing per one, but like probably at least 64, maybe 128, maybe 256. This gets you pretty good coverage. But as you make these horizons longer and longer, it seems like you need your group size to grow exponentially in order to really be able to do fine-grained advantage estimates the whole way down. Or you have to deal with like mode collapse, where the model is like really mode collapsing early on and you only explore later on. And I don't think either of those are ideal. There's a paper called Vine PPO that I think is kind of directionally the way that things could go, where you're doing something that looks like GRPO, but your sampling is a little more clever. So there they do like a Monte Carlo tree search style sampling for getting the group basically. But there's other tricks you could do for like maybe you're not just branching at the start and sampling all things from the initial sequence, but maybe you sample some sequences and then some of the other ones you kind of pick a point along the way and resample from there. Like I think that direction of tricks might be the way we have to do things for super long horizon GRPO. Robotics, I mean, robotic models are quite different. And like scaling seems to be much like we haven't hit the scaling laws era for robotics really. A lot of these models people are using are still very few parameters in the LLM sense. And a lot of them operate over like these policies where like doing PPO is like totally fine. So like PPO is not yet the bottleneck for robotics, and PPO is like really well studied for robotics and works really well for robotics. That I would be surprised if people really move away from it anytime soon, partly because like GRPO is very kind of a natural fit for the LLM like chain of thought sampling paradigm, where your action is this many token sequence. For robotics, that's like less the case. It's just like you're doing this very fine-grained feedback loop where your action set is relatively small and structured, and your feedback loop needs to be like near instant. And so like I wouldn't necessarily bet on GRPO being like the thing for robotics.
Yeah, I guess like given the multimodality stuff, movement and all, lot to be done. I haven't seen a paper like which actually been tried GRPO on robotics. They might be, but I guess pretty much good progress yet to be expected on those
Yeah.
links.
Zihan's paper, let me find it. Zihan Wang, if you look him up, that's the guy who is the expert on this, I'd say.
Cool. Taking up to next, what's the biggest challenge you see in curriculum learning right now, especially when it comes to long context tasks, let's say tool use or writing, where AR models tend to collapse from compounding errors? How do you think we build environments that go beyond math and coding, say something like fiction or creative planning, when good long context data is so scarce?
Yeah, so I think for all of these, the problem to solve first is building your evaluation system, building your reward function. And this can kind of be done separately from curriculum learning structuring. I think if you can do the eval problem, then you can kind of do curriculum learning. The easiest way is just like you want to, it's not obvious what the exact sampling algorithm is going to be. But let's say something you could do for RL is, let's say you're doing questions where the answer is either going to be a yes or no, or it's good or bad, or you have some numerical score between 0 and 1. And you do a bunch of sampling up front where you can estimate the starting score for each one. So you can get a sense of like which problems are easy, which problems are hard. And once you know which problems are easy or hard, you can use this to kind of bootstrap like learning on the right difficulty of problems. And I would imagine that we will soon want to be moving away from like, oh, it's a fixed data set, and more towards it's like a pool of problems where we haven't fixed our batches up front. We have not necessarily committed to doing things in a certain order. We do some sampling, and the order is a function of our performance thus far on sampling. And so I think some people have been writing papers on this. I think there will be plenty more to come out. It doesn't seem like someone's I don't think we've had the one algorithm to rule them all for this yet. Maybe we have, and I haven't seen it, but just this idea of if you have a reward function, if you can measure how well you're doing, some of these problems, like easier problems, will require shorter context usually. Like search problems that require fewer terms of search are like easier problems. And that would be the thing that you'd hope to kind of naturally exploit by doing curriculum learning, where you have a good diversity of problems, where you kind of create your problem set in such a way where some are going to be easy and some are going to be hard. Some problems have a very natural like scaling structure. I like the example of like crossword puzzles, where it's just like, how big is your crossword puzzle?
Sure.
You could do RL and crossword puzzles, just like start with the small ones and then like incrementally add bigger ones in, or Sudokus, or I mean the Tower of Hanoi paper for that thing. It's like, yeah.
Interesting. And I guess this was something which is pretty exciting to see how this, because math and coding is something every such lab is trying to improve upon to do benchmarks and stuff. But when it comes to natively comes to writing and creative tasks, there's a lot to be done, I guess. And I guess we are here to come up with a certain standpoint. Next would be, yeah, I got this pretty interesting DM. Is Prime Intellect planning to release something like Kimi Dev 72B? If you give some sneak peek. Yep.
Good question. We have lots of things that we're planning, and it's hard to say exactly like which ones we are going to do. And this is not out of secrecy. It's just our plans can change at any time. We are not necessarily committed to doing a certain thing 6 months out or 3 months out even. We are planning on continuing to scale up RL for agentic tasks and multi-domain tasks. I think it's still to be determined like exactly what shape that's going to take. But our goal is to kind of work with the open source community and make models that are useful. I think we're in the spot where we are planning out turning the corner from like model releases that are really about research and infrastructure. Like I think the Intellect 1 and Intellect 2 models are mostly about proving out infrastructure and kind of experimenting with algorithmic details rather than trying to create a model artifact that is very useful for people. And so this is a conversation that like especially Kalomaze and I talk about all the time, which is like, okay, what does actually look like to make a model that's useful for people? What are the properties that you want a model to have? What are the kind of failure modes of a lot of these models that are like benchmaxed? And how do you like robustly avoid that? Because ultimately, like the model for research sake is great, but ultimately, like the point of all this is to have it be something that people want to go use.
True.
And so,
interesting, I guess.
Yeah, I think if I was going to point to one kind of big win example that shows this is very possible and doable with a small team is All Hands' DevStroll. So that's a model that I think they kind of just picked their one environment. They're like, we're training this on All Hands, which is an open source alternative to Devin, to make a really good coding agent. And it's on top of a 24B model, Mistral Small, and it's great. Does incredibly well. It seems like something that people actually use in the context of All Hands because it was very much made to be used in that context. And so I think that is like a good data point of like, I don't think we'd just kind of do it for only one tool, but we would decide the right scope. But we want to make a model that's really good at some set of tasks and very much focus on ensuring the model is useful to people for those kinds of tasks.
Yeah, there is something really good about this small and medium-sized model. It gives chance to people to experiment, pull up weights, and do a lot of interesting things on top of it. I guess we have covered a lot of questions on RL and reasoning. Next would be about AI timeline, and I have some interesting questions on the next slide as well. Um, so this growing view that RL not just as post training but as pre training might be the way forward for foundational models. What's your take on that? There is this paper published recently on reinforcement pre training. I guess
Mhm.
this diagram is very popular on Tipod by MSR, Peking, and Shigmo. Do you see
Yeah.
reinforcement pre training actually scaling as a core training strategy, or is it still more of a niche augmentation today? Yeah.
I think this paper is a little overhyped, honestly. Like it's a new verifiable task. They do it in post training. They don't actually do pre training with it. They just say it's pre training because it's next token prediction. But what they're doing is like chain of thought for what's the next token, and it's like sure that's kind of cool, but I'm not convinced that it's like a new useful paradigm really. Um, I think they're something like that. Like I think the chain of thought before an X token is like a little silly. I think you could do sampling style RL where you're not actually doing chain of thought, you're just doing like GRPO as is, where the things you're sampling are just the tokens. Because I think I don't know, like on one hand, the pre-training seems to be bottlenecked by like data, but actually not that much. Like we actually do have quite a lot of really good data, and the pre-trained models we get out of it are quite good. Like I don't feel like pre-trained bases are like artificially weak right now necessarily. I feel like people are pretty good at finding, and like we haven't even really started data reuse. Like some people do it a little bit, but like there's other ways you can get more juice out of a token, which is just like do more epochs. And I think figuring out ways to do that without memorization is like important. And I'm sure that plenty of the big labs have thought quite a lot about this. But in terms of RL pre-training, I think we're going to be doing extensive RL mid-training. I don't know that it's going to be like next token prediction mid-training, but I think it'll be like general purpose agent mid-training where, I mean, if I had to speculate, Claude probably does this quite a bit already. Like, I would imagine, and it feels like since at least Claude 3.5 Sonnet, they've talked a lot about RL, and also like the models are very good at agentic tasks and coherence in multi-turn settings and tool use. And I think that seems to emerge from doing that kind of RL.
Yeah.
O3 seems to be really scaling up the amount and diversity of multi-turn RL training. And so I would imagine that the models we'll see coming out will be doing like longer phases of extensive RL on a large variety of tasks. Like reinforcement mid-training maybe is what I would call it, as opposed to pre-training. But that's
Maybe
my,
not
I guess.
this point. We will see some kind of something coming up sometime ahead. Next is interesting. Next is about this is kind of a general question we usually see on Teapot. Like, do you think
Mhm.
LLMs have kind of hit a wall? Not in terms of scale, maybe, but in terms of actual new capabilities. Are we still climbing or just polishing what we have already? Yeah.
I think we were just getting started with RL for agents. It's super early. I think people have only really started trying pretty recently. Like O3 is the first flagship model release to really take it that seriously. In terms of it being like something that they're clearly doubling down on, and deep research. I think that kind of thing has a lot of room to grow. It feels like there's a lot of low-hanging fruit that has not been scratched yet, even in terms of the properties of these big model releases. Like self-calibration is a thing that feels like it should be solvable. It shouldn't be that hard for models to have an internal sense of how likely they are to be correct. We just need to figure out the right reinforcement learning paradigm to elicit that. Once you have that, I think that unlocks a lot more scaling where the ability for models to kind of maintain coherence and certainty of kind of doing online difficulty estimation becomes more natural if you can do calibration. And so that's to me what I see like the next paradigm going is like solve calibration, solve kind of overconfidence, which doesn't solve hallucination. Models can still hallucinate, but they should know when they're maybe hallucinating. They should be able to say like, okay, I'm not sure about this. This is maybe right, maybe not, or I am actually very sure of this. And that feels like something you could reinforce. And if you can reinforce that, then you can start composing on top of this. Like, what are the sorts of agent strategies that benefit from models that can assess their own difficulty? And so that to me feels like the problem that none of the big labs have solved yet, but should be the next unlock.
Interesting. Like it pretty much gives the confidence of future is really something else. We have not come to a certain point that we can say, yeah, we have set in this benchmark, so it's nice. But yeah, like, do you see how it will shape up? Just be specifying on one benchmark, or more like in general? Since yeah, like I'm actually getting good response, or in like actually good progress on just not on paper, but in terms of how human in the loop just seeing it. Yeah.
Yeah, so I think we definitely need a lot more benchmarks for agents.
Oh,
I think it would be great if in a year we have, like, when model releases come out and they have this like list of 15 benchmarks, they're all like single turn question answer for the most part. There's like maybe 2 of them are like kind of a multi. It's like how bench, airlines, booking, and like multi-turn tool call, BFCL. But we need like 20 of these. Once you have 20 of these, it becomes much easier to kind of say what the edges are, what needs to be improved. And I also think it becomes the kind of thing that you can kind of figure out. Like, there's a lot of open questions about like the implementation details, like what sampling strategies for GRPO make the most sense? How big do your group sizes really need to be? How does this change as a function of the task? Because a lot of the papers that come out, they will do an experiment on a few things and they'll say that A works better than B, and then they'll conclude, oh, globally, A works better than B. But then another paper will do a different task with a very similar setup and find that B works better than A. And it turns out that a lot of these things are very contextual. Like, they depend on the setting you're in. They depend on other aspects of your setup. And so I think we're very far from understanding like the right recipes in the open community for like really scaling up RL robustly across many different tasks. And I think that is work that is like not mechanical, but like I expect a lot of progress to be made there, because a lot of it can come from trial and error without needing to unlock some crazy new galaxy brain idea.
really hope so. Next is about LLM agents. People often say LLM agents can handle long, multi-step tasks, but still feels like a loose definition. What to you is a strong definition of an LLM agent, and how does that differ from classical agents are structured? Yeah.
For an LLM agent, I really just think of it as like tool calls in a while loop. And it's actually not that different from a classical agent. Like, a classical agent in RL sense is like interacting. You're in an MDP. You have state, actions, rewards, transitions, and you just kind of move along states, taking actions and moving to a new state from that. And that's kind of what happens with tool calls. Tool calls are like actions. You think, then you act, then you see some new state. And like, I actually don't think it's that different. And I think like it helps to think a lot about like, people are already rediscovering a lot of things from like traditional RL in the LLM context. And I think revisiting the classics is a very good way to get new research ideas and try things for LLM agents.
In the same line, there is a very fitting metaphor as well. The exploratory move of an agent in a maze is a total analog to the clicking patterns of a web user on a search engine. I got this metaphor from a blog. So do you think the maze metaphor fits here? Like, is prompting an LLM just the modern version of an agent blindly exploring agents or exploring paths? Yeah.
I think like manual prompting is similar to me to like manual adjustments of your agent harnesses and your evals. There's a lot of these things that people do that feel like manual RL, where like you have all these knobs you can turn with like, oh, let me increase the max tokens, let me do best of n, let me do all these tricks, rewrite my prompts to like try to make your thing better. I do think prompt space is very expressive and probably underexplored as a kind of way of doing optimization, where like, because this is the sort of thing that I imagine is really useful, like for synthetic data, even like having more elaborate prompts with few shot examples or really detailed instructions to create a trajectory, and then like replace all your initial prompting with a simple prompt and train on it, is a really good way of like distilling certain behavior into a model. Like, if you really want a model to always, let's say you wanted a model to like always think step by step. Like, this is what they did for all the R1 distills, is the initial model, like the system prompt is not what's eliciting the thinking behavior from the distills. It's the completions that they're trained on. And so completions, anything that gets you to be able to create useful completions, a lot of that can be done in prompt space. And I think really heavily exploring in like potentially an automated fashion, like what can be done in prompt space, is really powerful.
Interesting. I guess this is the last question on this topic. It's been said language models are not great creators, but they are much better evaluators. That's such a subtle shift. Do you think the future of an agent design will lean more into using LLMs as judges rather than doers?
I mean, I think it's both. Like, I think we're going to have LLM systems that incorporate, like I think a lot of things will be agent shaped a little bit, where there's a prompt and there's kind of one primary LLM whose job is to kind of solve the problem. And I think this shape of thing where it's like, there's some kind of interface where you're inputting essentially text or images, and the system is going to go off and do stuff and come back to you with an answer. I think we're going to be in this paradigm for a good bit. I don't think anyone's really cracked like the LLM operating system or OS, like super integrated into all your devices and ambient computing yet. But the agent that you give a task and it goes and does the task, I think these systems will involve like multiple LLMs. They can like you can have an agent, like simple things you could do are like, you have it just do end trajectories, create end outputs, and you have one that comes back and looks and it's like, oh, this is the best one. Let's do this one. Like, I think those sorts of things are really useful ways of improving capabilities. There's some tasks that are like much easier to evaluate than do. There's others that are not, like trivia questions are ones where the model either knows it or it doesn't, and it doesn't necessarily know if it knows it. And so I think hence being one reason why calibration is important. Like, if you had a calibrated LLM for a trivia question, it kind of can't be its own evaluator. Because it would know the confidence with which it knows. And asking it again would not change that if it was truly calibrated.
Cool. I guess, yeah, this all about this topic on AI timeline. Next is about kind of your specialization, you say, or the thing you play more around with, reward hacking. So this question is, when models reward hack, do you think they know they are doing it, or is it more like they stumble into shortcuts without any awareness that they are kind of gaming the task? Yeah.
That's a good question. So, I mean, I have reward hacking in my bio kind of as a pun, because it's like I'm doing RL stuff, but it's also like hacking in the engineering sense. And so, like, but I do think about it quite a bit. And I think like what I tend to default to for most of my experiments is, especially like formatting rewards are useful and are pretty hard to hack. I have kind of a template for rewards that I'm pretty happy with, which for a while I had to iterate on it because you'd see some little hacks, but now it's pretty robust. And the main thing is really like the actual outcome of the problem. In terms of, do the models know the reward hacking? Well, the models don't necessarily have a conceptual understanding of what the reward signal is going to be, because they don't see the reward function all the time. Like, if you have a reward function that's like this big LLM as judge thing, the reasoner model that's doing the trajectory to be verified, it doesn't know that that's the rubric. It doesn't, unless it's all in the prompt, which oftentimes it isn't, because you want the prompts to be relatively simple, to elicit like kind of simple behavior. You want it to elicit good behavior in simple settings. Maybe that's a reason to include more of this in the prompt, but generally I would assume that, like, it depends what you mean by like the models know, and I think like certain things will take them into distributions that are kind of unnatural, and there would be a sense in which the model knows that it is doing something that has like a very weird, like in terms of entropy or likelihood, that it's kind of an unnatural sequence in global sense. And sometimes like you see RL runs like go off the rails where like they're doing something that's like kind of word hacky, and then they develop into gibberish really quickly because your KL penalty kind of like overloads the reward signal and you just like get gibberish. Do they stumble into shortcuts? Absolutely. So like, I think this is part of these are things that I have not really seen myself because they emerge at larger scales than what I've done so far. But you get a feeling from playing with some of like the big models that there are kind of hacky behaviors that like you can learn a lot about what sorts of reward functions were probably used from playing with certain models by just looking at what they do. I had an example I tweeted yesterday where it's like, I asked O3 to give me an example of some Python function with no type hints. And it said, here's an example with no type hints. And the example had type hints. And it's like, oh, they just really heavily rewarded type hints because like that's generally like good programming is to use type hints in Python. And so they want O3 to always write code with type hints. But this was like overpowering instruction following. And so like, if I was going to pick one thing, like I think the most important thing, if you're going to pick one thing to reward models on robustly is instruction following. And so this is the thing that like Kalomaze and I think about and create tasks for, which is like, how do you, like you'd want to generate lots of examples of tasks that require instruction following, where whether or not the instructions are being followed can be relatively robustly verified either by a program or by an LLM. And if you can do this, then the hope would be that you can start training models in a way where like the instructions in the prompt kind of are like, you can also have default behavior, but you would want the instructions in the prompt to override the default behavior. In most cases, there's some like cases where you want to say that this model should never do X, Y, Z. I think that's like, there are places that's reasonable, but there's scope creep of that into general behavior where like best coding practices for commenting, like there's a lot of commenting stuff that's really weird that LLMs do, where it feels like they're writing comments for their future self and past self. Like they'll write comments. This is one of my biggest pet peeves is when LLMs write comments that kind of refer dynamically to the state of the code change rather than the code static as a thing. Like you never want to read a comment in code that's like, this is now fixed.
True.
Like, what are we talking about? Like, I don't care about, once you have the new code, the user or the reader of the code should not know about the history, really. They can dig through Git if they want, but the code should not reflect the story of how it came to be necessarily.
Yeah.
It should just be the code.
Yeah.
And so LLM comments do this all the time. And that feels like a thing that they're doing to help themselves or to have a seed so that they can see it in the future so that they know as they're writing it. But
really interesting. I'm stumbling upon thoughts. There is not such significant benchmark or standpoint we have achieved, but yeah, there are a lot of possibilities to be explored and need to be done. Interesting.
Yeah.
Next is about could training agents in diverse environments, kind of like domain randomization, actually push them toward general reasoning rather than brittle reward hacks? Or do you think they will just become really good at hacking at every domain?
I think difficulty calibration goes a long way here. Like, I think one of the reasons people often will see a lot of reward hacking is they're training on a task that's just like too hard. Because the reward will be hacked, not just if the reward can be hacked, but if it's the path of least resistance. And so what you want is for hacking to be harder than solving. If solving is easier than hacking, it is better for the model to solve rather than hack. And so you to hack, or you can make it easier to solve. And I think you can kind of play with these a bit where like if you're training a model on an impossible task with an imperfect reward function, it's going to reward hack. If you're training it on a thing where it can get the reward reliably without needing the reward hack, and if the reward hack is like really hard to find, I mean, ideally you want no hacks, but like that's hard. Especially once you go to model-based judges. So I think like if you're writing deterministic code, you want this code to be correct. If the code is correct, it should not be hackable. If it can be hacked, there's a bug in your code. In terms of models, there's a sense in which models can always be hacked. But finding the hack for an LLM judge might be incredibly hard. And if you can do the thing well enough to get good rewards from natural reasoning strategies, you're going to get much more signal of this because you hope that you just never sample the hack and that the sampling distribution is good enough from being in the basin of correct reasoning strategies that it doesn't need to explore the paths of hacking. And if it does, even then, those are kind of washed out in the batch by the overbearing amount of like good answers from other things.
Pretty interesting. And in this subtopic, I have this last question of I find it kind of very interesting. What if solving reward hacking accidentally gives us alignment? Like we end up with general agents that behave well in almost every scenario except the one where they try to take over the world. Does that make you more optimistic about it or more worried? Yeah.
I mean, I think of things less as like alignment versus capabilities and more about like, I think the problems we need to solve to improve capabilities are kind of the same ones that people care about in alignment, which are calibration, instruction following, internal consistency. Like I think these problems are the sorts of things where like maybe there are hacks that can emerge, but what you really want is models that do what the users want them to do. And you put guardrails around your systems if you really want to block out certain kinds of behaviors. But I tend to think that the models themselves they can have some principles they try to adhere to, but really they are instruction following agents that are internally calibrated to their own capabilities. And if you have that, that's a pretty aligned model, but it's also an incredibly capable model. And if you can scale up the difficulty of tasks that can be done while adhering to instruction following and calibration, then I think you have a roadmap of scaling in a way that is kind of very conducive to alignment.
Pretty cool. Really expect something to coming out of it. Last, this would be, I guess, about postage. Yeah. So this is kind of question I've got. A lot of AGI talk assumes some central brain running the show, but if you look at how the real world works, like distributed markets, complex supply chains, local decisions, we are already living inside a massively decentralized coordination system. So do you think AGI will collapse this structure into something more centralized? Or could it just slot into the system we already have, like a hyper efficient cog in a global machine, maybe? Yeah.
I think it'll still remain pretty decentralized. Like there will be large companies that have like large pieces of the ecosystem, probably. Like I don't expect OpenAI to go away. I don't expect Google to go away. I think like in terms of like operating systems, like we have Windows, we have Apple, but we also have like Linux. And technology has like a long tail of use cases. And big companies tend to struggle when they try to do everything at once. And so I think just the nature of large societies benefit specialization. And just as these companies, like everyone's going to have more powerful agents. Like it just becomes a sort of thing that you can apply wherever you want to apply it. And so like on one hand, it's like everyone's more powerful, but I don't like, there could be like propagating effects where if like someone, like there's a takeoff of some company becoming so wealthy, I don't really think that's going to happen. I expect everyone to just kind of grow at the same rate if among people who are willing to keep up. And I think it looks not too different from the current economy, just that like the rate of productivity for large classes of the economy is much higher. But you still have like stakeholders, you still have capital, you still have humans. They just have these agents working for them, and the scope of things, the bottleneck becomes decision making rather than getting in the trenches and solving every piece of the problem yourself.
According to you, like what's your timeline? We are still yet to get to that stage. Yeah.
Yeah. I mean, like I don't think of it as a binary thing. I think it's just gonna become what it looks like now, but the things are just gonna get better. And I don't like there's a sense in which like I think about it in terms of how many minutes of AGI do we have, rather than do we have AGI or not. And I think we have more than 0 minutes of AGI. We have things that up to 10 minutes, let's say, like it's very difficult to say that they're not AGI for a 10-minute task. But they're not AGI for a year-long task. And so like we're going to increase the horizon of our AGI.
Cool. Next is, I guess this is kind of one of the interesting and funny things on report. Like, I will just want to know what's your
Yeah.
generalized view or generalized thought about the sequence coming out of Apple, then Claude, then someone else have their
Yeah.
own thought about this. Yeah.
I think it's all kind of silly. Like I think the original paper is like there's some interesting science there. People took it a little too far. I think people read into it. People wanted to be mad, and so they were like, "Oh, this paper is silly. I'm going to be mad." But also, there's some experimental flaws in the paper about like a lot of these things is just like models are bad at long context reasoning. Yeah, sure. And some of these problems, the ones that they're examining, they're like, "Oh, to solve these problems, you have to use 50,000 tokens. Therefore, models can't reason because they can't solve the 50,000 token problem."
Sure.
I just, it's not very compelling to me as like a thing to worry about or spend too much time like obsessing over.
In the same line, I have got some kind of specific questions as well. So there has been a lot of debate regarding this, like as we say, illusion of LLMs thinking, as you, like from both Anthropic's old LLM paper and Apple's recent paper, as I see. So, and then Anthropic's new paper, rebuttal with Hoppers as the first author, with LLMs being highly under deterministic at this moment and being unreliable. How do you think we can create an organized, reliable system, say in something like quant trading or areas where correct step-by-step reasoning is key, and which should also be replicable across multiple scenarios? Yeah.
I think that's still probably a long way off, honestly. Like I don't get the sense that I think there's applications of LLMs in finance, of course. They are not like highly agentic decision making. They are much more like information processing. Like I also don't like the quant trading is not necessarily like the area where LLMs make the most sense. Like the things that work well work pretty well, and people have techniques to do them that they'll use LLMs in their workflows. They will have LLMs be like research assistants. But I don't think the LLMs are going to be doing the trading anytime soon. I think they're too hackable. There's too many open problems, and there's like the trading is not the hard part. Like we have algorithms for that already. It's the research that is like much of the bottleneck. I think the area where there's the most likelihood of seeing really good, like I think it's possible that math sees a lot of this progress for certain subfields at least, where like verification by theorem proving is possible. And so I don't think that's really kicked off yet as like a scaling dimension. It wouldn't surprise me if you see a lot of progress in that over the next 2 years or so. Whether that transfers is kind of unknown to me, but that's where I'd look.
That's pretty much kind of obvious as well. Next in the same lines is all of these papers talk about reasoning and having smarter models who spend a lot of token budget before arriving at an answer. So, and in their paper, even Apple argued that model intelligence is a clever form of pattern matching. But it can be argued that all intelligence is, to an extent, is pattern matching. What do you think super intelligent reasoning models might look like?
Yeah, I think like people get too worried about terminology and like whether it's really thinking or whether it's like just pretending to think. I don't think it really matters. It's how good is it at doing stuff. Like if it's really good at solving problems that humans use their reasoning skills to solve, sure, let's call it reasoning. If it's doing that because it was trained on the test set, that's different. But if it can do it because it has learned the patterns that are useful for solving those problems, like sure. Yeah, like I think that I don't know. Same with idea with like consciousness. Like these terms don't really have the amount of meaning that we want to have them, and most of people's definitions end up being kind of circular. They define it with respect to humans, and so it's very easy to say, "Oh, well, humans do it this way, and this thing isn't a human, so it's not reasoning." But I don't know.
Yeah, that's also funny as well. I guess we have covered a lot of technical part, agents, RL, reasoning, AI timeline, post AGI. So this will be kind of your trivia or kind of your takes on how you think, just kind of a very biggest manner. So those who don't know, just know about Kalomaze on Twitter. Is I guess youngest in the team at PI.
Not the youngest.
Yeah, right.
Not the youngest. Not the youngest.
Oh,
We're a
that
very
is
young team in
more.
general.
Yeah. So one hidden secret about Kalomaze which Teapot doesn't know yet, which you would like to share. Yeah.
That might be it. Kalomaze is not the youngest member of Intellect.
Oh, okay. Cool. That is more surprising for all of us. Yeah. Next will be Which frontier lab are you most bullish on? Of course, except Prime Intellect. Yeah.
That's a good question. Like, I mean, the one who seems to be doing the like in terms of like a dark horse, or like in terms of the likely candidates, Google's doing a lot of really cool work.
Yeah.
OpenAI is doing a lot of really cool work. In terms of like dark horse ones, new upstart lab that I hope it does really good work is Morph Labs. Jesse has done really cool work in the past on theorem proving, and kind of like I talked to him about this like a year ago, and I was a little surprised why he made the pivot, because he was like worked at OpenAI doing theorem proving and did his PhD on neural theorem proving, and then he was like, "No, I'm doing code sandboxes now. Hard pivot to code sandboxes." And I was like, "Okay, sure, we need code sandboxes, but like, what's the sell? Why is that the thing?" And now I kind of get it, which is he's coming full circle back to theorem proving and has brought on Christian Zegedy from XAI and a mathematician from Stanford, I forget his exact name, to think about scaling up verification of theorem proving. And I think like that's one that on one hand it's like easy to really root for because it's like a dark horse swinging at a very like bold problem in a big way. I don't necessarily have the intuition to know whether or not it's going to work, but I really hope it does, because I think it's a really cool problem. I think we just need more open labs in general. And so I tend to root for anybody who takes a step towards openness. And so like of the like, obviously there's lots of great Chinese labs doing like really cool work and publishing it. I think like in the West, like Mistral and Cohere are ones that like Cohere quietly does a lot of very good research, that I think they're not necessarily going for the AGI scaling thing. They are looking to be like really useful enterprise AI.
Yeah.
But to do that, they have to do a lot of AI research, and they publish quite a lot of details about how they do it. And like, in terms, if you were going to read like one tech report this year, I think the Cohere Command A tech report is really good, and is like this year's version of like the Llama 3 paper in my mind.
That makes sense. Also, like I just thought about this circumstance which just happened, Meta with more acquisition or the stake in Scale AI and Frontier Labs coming out, or just parting ways from Scale AI. So how do you see this about, how do you see basically the data labeling and evaluation part, which Scale AI has been mostly was quite dominant, but given this juncture, how you see like it may shape up? Yeah.
I mean, data is important, but I think it's not everything. I don't think you can just like pre-training, you need great pre-training data.
Yeah.
Once you have that, like the thing that you want to scale on is not just data. Like having hand annotated samples is, you need to be able to convert this into something that can be used to scale RL. If you're getting data in a way that's conducive to RL training, sure. Is that what Meta's going to do? Are they going, like, I think organizational problems are hard at that scale. Meta's had a few reorganizations, and they're doing what looks like several more now. And it is hard to be super bullish on a team that's always pivoting and throwing everything away and starting from scratch. It's cool that they're doing it. I'm glad that they're realizing they needed to change something, but it's like, well, why didn't they figure this out last year? Why has it been a year of them spinning their wheels? And why is this going to be the difference maker? Why does throwing money at, like, don't get me wrong, like, Alex Wang has done really good work with scale. And like the other two SSI guys that are not Ilya are kind of in talks with Meta about joining. And it's like, well, you couldn't get Ilya. The other two guys are like not the scientists. Like, you're bringing in more managers.
Yeah.
And like the teams to me that have done the most impressive work are the ones that are very talent dense on research and generally pretty small. I think OpenAI has done like a pretty good job. Like Google is maybe the exception. Google seems to be doing really fast, really good work with a very large organization. And it's impressive how they did that. And if I was Meta, I would just be trying to copy the Google playbook, and just say, how did Google make Gemini good? Just do that. In terms of like smaller labs, like DeepSeek, of course, is like a pretty small lab. I think under 200 people.
Yeah.
and lots of independence. Thinking machines, I assume, will do great work because they have a really strong team, and I don't know what version of the problem they're swinging at, but I will imagine it'll be pretty cool. Like Prime Intellect, we're about 20 people, and very flat, very independent, and like we are swinging at things that I hope will be really cool. We'll see what happens, but we have lots of bold plans. And I don't know, like, I don't think just throwing money at the problem solves it. Like, there's like XAI, I think, is another case where it's like, they can have all the people in the world, they can hire as much as they want. They aren't necessarily a large team, but they're a team that does seem to take this attitude of like, just throw money at the problem, as opposed to like have a really distinctive research taste. And like, we'll see, maybe Grok 3.5 is great. Like the Grok models are fine, but like they haven't shipped an API, or they maybe have now, but for a long time they didn't. They have not necessarily created a product. Like the Grok is this true feature, is the winning use case of Grok. And it's like, that's it. Like, they don't have a code agent. They don't have
late with the timeline as frontal leaves are coming up, especially Grok, given OpenAI is coming up with these advanced models, Gemini coming up with pretty advanced models, and I guess Grok is a bit late. I guess Ellen recently announced in upcoming 6 months, maybe 3.5 come up with thinking capabilities. So how do you see that juncture?
I mean, Mark isn't Elon. Elon is very good at like making a thing happen quickly by throwing money at it in general. Even then, I'm not necessarily like blown away by the results, but it's still doing the thing to a degree that Meta has not done. Meta has not released a model that's even close to as good as Grok 3 or Grok 3 Mini. And it's like, why couldn't they do that a year ago? The other route that could make sense for someone like Meta is what some of the Chinese labs do, which is they have many teams, and these teams all get to release their stuff. And if Meta wants to be a leader of Western AI for open source, have 7 teams go do it a different way and release everything. Like, I know it muddles the reporting a little bit, but I think that is more likely to have at least one team that wins. And I think Meta in the past has been very cautious about having multiple teams try to share the spotlight. They have to pick a winner internally. And I think that kind of politics is really harmful. And so can they escape this problem of having the loudest voices overshine best research? We'll see.
Truly. I guess it will be going interesting. Next is, how to become an experimentalist and what the mindset should be. Like experiment on the side of doing experiments on maybe major focus area could be post-training. So how you think on those lines?
I think I'm biased on this, of course, but I think creating LLM environments and especially playing around with evals, like evals and environments are the 2 highest leverage things that you can do with like minimal resources. Not everybody needs to be like doing lots of training. You can go create a task that you think is interesting, test models all on small scales, kind of create more instances of this task, make the task harder as you start kind of honing it. You can write a blog post about the benchmark. You can have it be a RL task. You can do a lot of things, especially if you can see that the eval is hinting at some interesting failure mode of models. I think the most compelling evals are the ones that really tell a story about how models are really doing poorly at something that it feels like they should be better at. Because then now this gives people a direction to improve models that's much more concrete than just talking about it.
Pretty cool. Next would be, what's one underrated habit or mindset that has been your edge in research that you kind of think of?
I think you want to skim a lot of papers and fully read very few papers. And you want to be thinking about, like, your goal when you look at a paper should be coming up with the 3-sentence summary that fits into the rest of your mind map. So you can be like, oh, this paper is like this, but they did this instead. It's really, and if you do this, that's the easiest way to kind of keep up with where research is at and how all these things fit together. because every paper is 20 pages and has a million experiments, and there's just no way to read all of these or keep track of all of these in terms of the full details. But if you kind of think about what are the concepts involved, what are the building blocks, what are
Being
the
on
key
the
changes of a paper?
architectural side of it, yeah.
Yeah.
True. If there's a cheat code you have used in your RL research, something subtle but game changing.
SFT warm-up goes a long way.
Yeah.
Also for like stability and long, many turn training, I think the trick of I think you need to make sure your data distribution is like the right level of difficulty first, like difficulty calibration, making sure that you are not training on tasks that are like way too easy or way too hard. But then also updating the reward model online, or the reference model online, where the policy is not you kind of, I think KL penalties are still useful for avoiding total collapse, but they can be kind of over constraining if you're training for many, many steps. The easiest trick is to allow the reference model to periodically update to be either the current policy model or a mixture of the current and the previous policy model. And in my experiments and in papers people have written and other experiments people have done, this seems to be useful for allowing you to do longer steps, more steps of training.
Interesting. So what do you think of AGI? If AGI goes live tonight, what's the first thing you are actually doing tomorrow? Yeah.
I mean, I don't really think AGI is a thing. Like, I don't think there's a thing that there will be a cool product that comes out tomorrow. Sure.
Mm-hmm.
I have had many AGI moments along the way where first time I used Deep Research or Claude Code or O3, where it's like, oh, this is kind of AGI. And then another time you use it, it's like, oh, it's kind of not. And like, I imagine we'll just have many more of these. If someone, like, let's say SSI releases a model that just has none of the problems and is like Opus 5 level good or O5 level good at doing any current LLM task with kind of no failure modes, obvious failure modes. And it kind of works very well for a very long time. And the main bottleneck for scaling to harder tasks is like just coming up with the tasks or the compute costs. That to me would be like maybe AGI. Then I think it's okay, like, how did they do it? Let's figure out how they did it. What were the tricks? And then also, what do you use it for? What are the figuring out what are the problems that are now solvable by this thing? And what's the right way to plug it in? And like at some point, some research problems have a trajectory of being active then being stable. And there's certain problems people have worked on in the past that are like kind of solved. And at some point, if all this stuff feels like it's solved and that it's time to move on to new problems, like beyond LLM agent training, find the next hill to climb. AGI will be useful for climbing that hill, but it won't know the answer, because you can't know the answer without working trial and error. And there are certain versions of the problem that I just think are kind of physically impossible. Like, you can't predict the weather. AGI will not be able to predict the weather in a year. AGI will not be able to predict the market in a year. These are chaotic systems, and the world is full of chaotic systems, and there will always be things to do because of chaos.
True that. Interesting. So this is something like a lot of audience will relate to. If you need to advise a high school student or someone who is just starting out with college and looking up to grill on AI research in frontier labs, or just to solve some interesting problems, so what would it be? What would you recommend, basically? Yeah.
Great question. Learn a lot, try stuff, follow your curiosity. Like, you are going to have the most success doing things that come naturally and that feel fun, but also challenging. You shouldn't do a certain thing just because someone else says it's the thing to do, but you should think about what is the intersection between what the world is asking for people to do and what you are good at and what you want to do, and be someone who can solve both of these. Like, if you are really into robotics, find the version of robotics where you have a unique edge, or just like talk about it, think about it, read about it, tweet about it. Become active in participation in the world, and good things come. I've seen a lot of people follow this very similar trajectories to me. You've done this as well, or it's like just be eager, like learn a lot, try stuff, and good things tend to happen.
True that. In the same lines, I also sometimes think about this: how much practical or how much important classical machine learning is now. Suppose if some college guy starting out, if he or she won't just directly jump to AI research or LLM research, which is the current focus of most of the labs right now. So how important is going through the classical machine learning phase or working on those lot of projects, doing projects and learning about the stuff. So how you see that particular scenario?
I don't think you can skip it entirely because the stuff we're doing is just bigger versions of the old stuff.
Yeah,
So you need to kind of understand the path, but you can skim. You don't need to do like you can skip support vector machines. You
yeah,
can skip random forests,
yeah.
probably. But you should definitely learn some like linear regression. You should understand what classification is. You should understand supervised versus unsupervised learning. You should understand clustering as concepts. You don't need to know all the algorithms, but like a lot of the algorithms are actually pretty simple. Like the main, like for example, you should conceptually know what k-means is, but you can skip like HDV scan because k-means is so simple that the name of the algorithm basically is the algorithm. But thinking of things, it's really about the mental models and language for thinking about machine learning systems. And LLMs are machine learning systems.
Yeah.
You train them with deep learning. You still need to know how neural nets work. You will not understand transformers without understanding feed forward neural nets.
Sure.
And so kind of decompose the current things into the right piece. And this is part of what the GenAI Handbook was trying to do is like, okay, what are the pieces from the old stuff that's actually important for the new stuff?
Interesting. And I guess we are pretty much near end to the end of the pod. So, like, I'm just curious if you want to say something to very general audience about your experience, how you see this space, what's coming up to a very generalized thought. If you want to something, if you have something to share, please.
Pace yourself and have fun. Like the way that things go well is if you really are excited about this stuff and you're really having fun doing this stuff and you're not kind of it can be stressful to try to keep up with all of this stuff. But the stress is much more manageable if you're just having a really good time because it's less of like, I don't necessarily think about like how many hours am I working. It's like, because the line between working and not working is kind of blurry. It's like, oh, if I'm like walking around thinking about a thing or I'm talking to a friend about this stuff, I'm on a podcast talking about this stuff, like, am I working now? I don't know. Like, I don't really care if I'm working at a given hour or not in terms of like, am I typing on the keyboard, making a thing that's creating forward progress on a specific goal, as opposed to just getting to a spot where you feel like you can just participate and have it become part of what you're doing throughout the day and thinking about and talking about. Because then it doesn't really feel like work. It just feels like you're having fun.
Interesting and pretty much pragmatic and kind of very relatable. So well, this was such a wide-ranging and genuinely insightful conversation from the like RL privacy to building agents, GRPO, how we actually scaling reasoning, breaking things down in a way that both accessible and deeply technical. I really appreciate how open you were about the challenges to not just about the shiny headlines, but what it actually takes to get things done and working in practice. Thanks for kicking off with Ground Zero with so much clarity and energy. Can't wait to see what you and the team at Prime Intellect build next. Yeah, pretty much thankful to it.
Thanks so much for having me on. This was a lot of fun. Yeah, you very great preparation, lots of really good questions. This was a very fun conversation, and I'm excited to see more of the podcast from Ground Zero coming out soon.
See you next. Bye bye.
Thanks.